Practice final. It is finals week. I'm going to write on here that this is assignment basically 1 of 2 that is due on Friday. I will encourage that to be turned in by Thursday. But if you follow along with us today, you'll already have it done. So do that. This is due Friday. What would that be? September 19th, right? No, September 26th. Okay, and I will write instead of my name, answer guide. So the things you will need for this final. First of all, you will probably want a ruler. So I'm going to grab that. It never hurts to also have a compass and a protractor. So this is your protractor, this is your compass. You will need a compass for number 1. So if you do not have a compass at your table, there should be some at the front of the room in a bin on that shelf. So I will make sure everybody's got one of those before we get started. Side note, we need a compass for number 1. So whenever we are constructing an angle bisector, there are a few steps that we need to take to make sure we do it correctly. So step 1, I'm going to try to decide where am I going to put the point of my compass on my angle. Does anybody remember where we start when we're constructing an angle bisector? Yeah, that little dot. Anybody want to remember what that's called? An end point, but it's called something special when it's end point of an angle. I remember. It starts with the letter that this angle looks like. Starts with a V. Vertex. Yes. So first step, put the point of your compass on the vertex. And we're going to create an arc. Let me make sure my thing is tight. Okay, so we create an arc. Make sure that your compass holds its shape tight enough that you can make consistent arcs. If your compass is loose, like I have a loose one right here, I barely touch it and it moves, it's going to be really hard for me to construct things properly. I'm not going to use this one. Make sure you have one that's a little tougher to open and close because it'll be more accurate. So that's step 1. If you're worried you might forget, not a bad idea to say, put a little note on here. Point on vertex. That's step 1. Yes. Next, you're going to take your compass and you can keep it open at the same width as that first arc. You can make it a little bigger, you can make it a little smaller. It doesn't make too much of a difference as long as it crosses in the middle. The next 2 points you're going to put the pointy side of your compass on is these intersections we've created with the arc. So I'm going to put my point right here, and we are going to create an arc in the middle of the angle. Then we do it on the other intersection of the arc. Now, these 2 arcs that we're creating in the middle, your compass does have to have the same opening size, or else this 3rd intersection we create will not be in the middle, and I will be checking. Now, if you accidentally open your compass up and it's not the same size as this first arc, we can always go back and remeasure. Put the point back on that starting spot on this intersection and just move your compass until it lines up with that first arc you made here. Once that lines up, keep it at that opening. Go over here, double check, and we've got it. So we're trying to make a little X in the middle for the second step. So I'm going to kind of highlight that X with a color. And basically for step 2, we're creating 2 arcs using these intersections. So step 2, make 2 arcs. Point on intersections. To those intersections that we touched. Once you've done that, you're ready for the last step. We're going to put a ruler or a straight edge lined up with the vertex and that intersection that we've created in the middle. And we just trace a line going straight through, and we have successfully made an angle bisector. That's all you do. These are the 2 points we're crossing through. So I'm going to write for step 3, connect or draw a line. And there are going to be 3 points that you can earn on this question. And here is how you will get those points. So I'm going to write 3 points here. Here's where you'll get those points. Your first point will come from me seeing that you did make an arc for step 1. Your second point, so I'll write +1, that's your first point. Your second point is that these intersecting arcs in the middle are the same size, and they actually are coming in the middle, so that's plus another point. And then your third point is going to be from this line, the bisector, going through the vertex and that intersection. So that's your third point. If it does not go through the intersection, you won't get that point. So you want to be as precise as possible. If I drew my line over here, that's not an angle bisector. We're trying to split the angle perfectly in half. Any questions on number 1? Okay, can I move to number 2? All right, so for number 2 and 3 are actually kind of connected. We have parallel lines and a transversal, a line that goes through parallel lines. For number 2 and 3, we're going to solve for x, and then we're going to use x to help us solve for all the missing angles. So I'm going to zoom in on this photo here, and we're going to take a look at all these 8 angles that are labeled. And I see over here, I've got 2x plus 4, and I've got 78. Everything else is labeled with a letter. What do we know about angle relationships that might be able to help us solve for x here? Yes, C is 78 degrees. Those are vertical angles, right? They're right across from each other. So that's a good thing to note. Let me get pen here. I know C is equal to 78. Well, and that's one of the things they're asking us on number 3. I could start filling things in. C is 78 degrees. What else is 78 degrees? D. I see that D has one arc like C does. So I know D is 78 degrees. I could fill that in. What else is 78 degrees?
What did you do the one that is function?
Yes, 2x plus 4. is 78 degrees because D is 78 degrees. So I have an equation to solve for x. I can write 2x plus 4 equals 78. And we know that because D and 2x plus 4 are vertical angles. They're right across from each other. And we noticed that C was right across from 78. C and D were equal. So 2x plus 4 must be equal to 78. Okay, the other thing you will want is a calculator. Forgot to mention that earlier. If you don't have a calculator, please get one now because you can't use your phone as your calculator.
And someone will warn you before we start the lesson.
Yes, completely forgot. I know, guys. Sorry.
We have the,
Even though it's math class, we should have known.
Okay, perfect. So how'd you get the answer? What'd you do?
minus 4 from both sides.
Perfect.
Got 2x equals 74, and divided both by 2, and I got x equals 37.
Perfect. So we just subtracted 4 from both sides. We got 2x equals 74. And then we divided by 2 to get x equals 37. So don't forget to write for number 2, x equals whatever answer you get. And in this case, we got 37. So we've solved for x, but now I still need to know these other angles, A, B, E, and F. Is there anything I can do to solve for just one of those angles?
Just for one of them, A and 78, since they're next to each other, would be supplementary. So
Yes.
they would be 180 degrees, so you would
Yes.
subtract 78 from 180.
Perfect. Perfect. So James noticed that A and 78 are on a straight line. So they're supplementary angles, which means they add up to 180 degrees. So we could solve for A plus 78 equals 180. Just subtract the 78 from both sides. And someone tell me what the measure of angle A is. 102? Perfect.
And then what would we do the same?
B would be the same, wouldn't it? A is 102. B is equal to A because it's right across from it. It's a vertical angle. So I can go ahead and write A and B are both 102.
Is it the same for F and 2x plus 1?
Yes, F and 2x plus 4 is 180. Now, something that we can do to kind of help us is as we've labeled the angles over here, I find it helps me if I also label my picture, because then I can start to see it a little better. I know that C was 78, D was 78. This 2x plus 4, we could ignore it. That's also 78. I know A is 102, B is 102. And if I knew that A and 78 were supplementary, so A was 102, E and 78 are also supplementary, right? So what's E? 102. It's going to be equal as well, and F. So really, you just have to find the other angle measure. And since we have parallel lines here, and this is a transversal, these 4 angles are just copies of each other on the next line. So E and F are also 102. And that's a good thing to keep in mind, is just the relationship between those angles. So over to the side, I'm going to just make a little note. Let me get this thing to work. Okay. Make a note that if I ever have parallel lines with a transversal going through, if I ever have this, always these angles that are opposite of each other are equal, and the same for the next set over here. These are equal. So all four of these are equal to each other. And then I know the four on the side are equal to each other. So on your final, you will have a question just like this. The relationship between the angles will be exactly the same. Obviously, your numbers will be different, but as long as you know that those opposite angles are equal, those corresponding angles are equal, you'll be good. Okay, any questions on numbers 2 and 3 before we move forward? Okay, we got that? We ready for the next page? Okay, we're going to move on. If anybody at any point needs to still see this or previous questions, just tell me and I'm happy to go back. So we have surpassed all of the constructions, all of the angles, and now we're to the formula part back from Unit 1. We are looking at midpoint and distance. So we're going to need some formulas. I would recommend writing these formulas on your practice final so that you have them when you take your final. So the midpoint formula, let's write this to the side up here. Midpoint equals, remember the midpoint is going to be a coordinate, so we're going to start with a big parenthesis, and then we're going to have a big fraction with a comma, and another big fraction. And in that fraction, what we do is we just take x1 plus x2 divide by 2. And that's going to give you your x value of the midpoint. Then we move on to the y value. It's the same thing. y1 plus y2 divide by 2. So this formula is very important because you're going to need it. Now, once you do have that formula written down, we want to look at these points that I've been given. It says, find the midpoint of the line segment with the given endpoints. So we need to decide, what is my x1? What is my y1? What is my x2? What is my y2? Label your coordinates. It will make this so much easier. I'm just going to start with x, y. Oops, I wanted that to be blue. X, y, X, Y. And we'll call 12 x1, -8 y1. 2 will be x2, 3 will be y2. And now that I have my coordinates labeled, how will I plug these into my formula? What will I write?
Plus 2, 2.
12 plus 2 over 2. And then for my y's,
-8, 3.
Negative 8 plus 3 over 2. Good. Then you just simplify those fractions. Remember, when you have a fraction, you need to simplify what's on top first. So let's do 12 plus 2 is 14 over 2. And then negative 8 plus 3, what is that?
-5.
Negative 5 over 2. And at the last step, all we have to do is divide by 2. So 14 divided by 2 is 7. Negative 5 divided by 2 is negative 2.5. Perfect. So our midpoint is 7, negative 2.5. And then we're done. That's it. That's number 4. Number 4. Any questions on number 4 before we move to number 5? Or does anybody need more time to copy that down? Okay. So looking at number 5, now we're finding the distance between points. So I have points on a graph. I have not given you the coordinates. We're going to need to name these points with the correct coordinates. So the first thing I would recommend doing is writing over to the side your A and your B, and I would label these. And just like your midpoint, and at any points you graph, X comes first, then it's Y. So looking at point A, what would my X value be?
-5.
Negative 5. That's where it lines up. So negative 5 for A. And then what's my Y value for A?
+5.
Positive 5. Good. What's my X value for point B?
-2.
Good. Negative 2. And my Y value? 1. There you go. So we've got our coordinates. Now we're going to need to use, there's 2 different things we could do. We could use the distance formula, which is, write that down for us. We have distance equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So we can either use the distance formula, or we can actually use the Pythagorean theorem if that feels a little bit less complicated. I personally like using the Pythagorean theorem for this a little better as we move into the triangles. And the way we would do that is we can see that we've got a tilted line here. This is like the hypotenuse of our triangle. If I wanted to, I could draw the other sides of the triangle and see that they are straight lines. What would the side lengths be of this triangle? What would this side be? We just count the units.
4.
Yep, 1, 2, 3, 4. So this side is 4 units. My bottom side would be how many units? 3. If you don't want to mess with the distance formula because you're worried you might accidentally switch your x1, x2, y1, y2, whatever you do, you can do this. You can say 3 is A, 4 is B, and I'm solving for C. So A squared plus B squared equals C squared. I think this way is a little bit easier, but the distance formula works just as good. I'm going to show you both ways. So I'm going to try the Pythagorean theorem first. Make A 3 B will be 4 C squared. Oh, not 3 to the third power, 3 to the second power. And then 3 squared is 9 plus 4 squared is 16. Bring down equals C squared. What would I do from here?
I have 16 and 9, which was 25.
So I get 25 equals C squared. Yes, and then you square root it. And you'll get C equals 5. So your distance is 5 units. And if you just did this, I would take this as the correct answer. I will also show you using the distance formula though, in case you prefer that. So if I use the distance formula, I would want to label my coordinates first. Say A is my x1, y1. B is my x2, y2. And so I would just plug those values into my formula. So I have D equals the square root of what two numbers am I subtracting in the first set of parentheses? I've got -2 is my x2, so I'm going to put that there first. -2 minus x1 is -5. Plus,
Should we break it up by some?
where? Here?
Yeah.
It will become a plus sign, yes. Because you've got minus and negative, so that's a good catch. Good thing to think about. And then we have y2, which is 1, minus 5. Good. And you're going to see we're going to end up getting the same numbers as down here. What is -2 minus -5 or -2 plus 5? Say it one more time. -7. Is it? If it was -2 plus -5, it would be -7. But I have -2 minus -5, which is also -2 plus. That's a +5 now. We've got different signs that we're adding.
3.
3. It's going to be +3. So that one you got to be careful on. So we have 3 squared now. Plus, what's 1 minus 5?
-4.
-4 squared. Bring down the square root. And look, you're doing the same thing. We had 3 squared and 4 squared. 3 squared, -4 squared. Is it okay that this is a -4 and this was +4? Is that okay?
Yeah.
It is. Because anything squared is going to become a positive. If I have -4 times -4, those negatives cancel. So 3 squared is, we already did that, it's 9. Plus, what is -4 squared? 16. And we bring down the square root. And then it starts to look exactly like what we just did. 9 plus 16. is 25. And we square root it. And look, we did the same thing before. The square root of 25 is 5. So you can use either formula, the Pythagorean theorem as a formula, or you can use the distance formula. If you're somebody that mixes up your x and y's and your pluses and minuses and your negatives, the Pythagorean theorem is going to be safer. But they both work. They both work. So I'll leave that up for just a moment and let that kind of marinate. If you guys have any questions about it, please let me know before we move on. This is the end of Unit 1. Now we're moving to triangles. Oh, and I forgot to tell you the point system here. Number 4 is worth 3 points on your final. So that means, if you get one of your coordinates incorrect, you could lose a point, but it's worth 3 points. So that gives you a cushion so that if you get it partially correct, you don't lose all 3 points. I'm going to be able to give you some partial credit for things that you do have correctly. And number 5 is also 3 points. And those points are going to come from all the steps you do in either the distance formula or the Pythagorean theorem, depending on how you want to solve this. Can we move to number 6? Does anyone need more time? So, number 6. These, I guess 6 and 7, they're kind of the same. These both are worth 2 points. One of the points comes from you showing your work, because these are yes or no questions. I don't want you to just guess yes or no. I need to see your work. So 1 point comes from your work, 1 more point comes from the correct answer. So for number 6 and 7, we are trying to state whether or not each set of side lengths could be a triangle. So you're given 3 sides, and we have to use the triangle inequality theorem, thinking way back to Unit 2. That theorem says that the 2 smaller sides of a triangle, when you add them together, they must be bigger than the largest side. So the first thing I would do here is I would circle the largest side length. For number 6, I have 42 inches, 23 inches, and 21 inches. What is my largest side length?
42.
42. So I'll circle that. That's my largest side. Now my other 2 sides, we're going to add them together. So 23 plus 21, what is that? 44. Yeah, so the question we ask now is that sum bigger than the largest side? If the answer is yes, it is a triangle. So I can say 44 is bigger than 42. So yes, it is a triangle for number 6. For number 7, what is my largest side length? Obviously, 38. That's my largest side. So we'll add the other 2 together. What is 5 plus 12? 17. Yes, 17 is not bigger than 38. So is this a triangle? No. That's all you'll have for your actual final. Just 2 other questions similar to these. And that's all you got to do to show me your work. Just show me that you're adding the smaller sides together. And that's all for the second page. Okay, are we ready to move to page 3? Does anyone need more time? Okay, moving on to the third page. Solve for all missing side lengths for each special right triangle. This is the part where you're really going to want to write down what I'm writing down, because I'm not giving you the x radical 2, x radical 3. I'm not giving you those measures, that you need. So you'll want to have them written on your practice final. So for number 8, I have a 45, 45, 90 triangle. In a 45, 45, 90, I have two sides that are equal to each other. From A to B, I have x. From B to C, I have x. And from A to C, does anyone remember the measure on the hypotenuse? No, we gotta really think for this one.
Isn't it sometimes too bad?
Yes, yes, you almost have it.
Radical 2
Yes, and then there's one more part.
times 2.
Not times 2. I already wrote the letter.
X.
X.
Okay.
X times radical 2 is my hypotenuse. So I'm giving you one side length. I gave you that from B to C, it's 18 inches. How'd you know that?
Because X is X.
Yes. Okay, so something that we can automatically see is, I know BC right here is 18 inches. And I already marked that X is BC. So I know X is 18. Solved for that right away. Easy peasy. So how can I use that to find AB?
If they're both X, then A would also be 8.
Perfect. They're both X. AB is X. 18 is X. So AB is 18 inches as well. Yes. Now to find AC. I know AC is X times radical 2. So I'm going to write over here. We're just going to plug in X. AC equals X radical 2. And if X is 18, we'll do 18 radical 2. So let's make sure that we remember how to type that on our calculator. I need to get my calculator out. For this part, I will literally just type 18. And then second button, the blue second button, and then the x squared button gives me square root of 2. Enter. And you should get 25.45584412. I want to make sure every person is getting that. Give me a thumbs up when your calculator says this. Perfect. Perfect. So I'm going to write that. Equals 25.455844. So that's what my calculator gave me. Do I need all those decimals?
No, just the first 2 of them.
No, just the first 2. I'll even take just 1. You could either put 25.5, rounding up that 4, or you could do 25.46, rounding up that second 5. Either one is fine with me. So I'm going to write 25 point, I'll do 46. And it's still inches. And that would be your answer.
Didn't you say we could do 25.45?
Yes, that would be fine. If you don't round up and you write 25.45, I won't count it wrong. As long as it's within like 0.01, that's okay. That's okay. It's okay. Not the end of the world if you don't. That's not what I'm grading you on. Just want to make sure that you know how to plug in your X. So for both of these questions, if you're worried you're going to see this on the final and forget where to start, step one is always find x. Once you know what x is, plug it in to find your other sides. Just 2 steps for these problems. Find your x and then plug that x in to solve for the rest. Now for number 9, we don't have a 45, 45, 90 anymore. We have a 30, 60, 90. My smallest side, across from 30, that's EF. That's my x. My second largest side, across from 60, that's DE. That is x radical 3. And then my hypotenuse from D to F is 2x. So keep that labeled. It'll be in the same orientation on your final. And I've been given that from D to E, it's 31 inches. Now this time I'm not just having x given to me. We'll have to actually solve for x. So something that can be helpful is going over to this given and find kind of set of information and labeling it with the x values that I've given you. I see that EF is my x. So I'm going to write x. DF, what is DF? 2x. And DE is 31, but what is it as x? What is D? Yes, yes. On the picture, we have it labeled as x radical 3. And now our equation has written itself. So what equation am I using to solve for x?
Oh, you just heard it. Right?
Almost. We're not going to square root it. First, let's write the equation. What equation am I actually writing? I've already kind of got it written, but I don't want to use units in there.
31 equals x radical.
Yes, yes. Here's my equation. 31 equals x radical 3. And remember, whenever we have x or a number next to a radical, this means x times radical 3. Radical 3 is just a long decimal that we don't want to write out because it would make our problem really complicated. But this is a multiplication problem, right? How do I get rid of multiplication so that I can get x by itself?
Oh, you divide by that.
I divide. We're going to divide by radical 3 on both sides. And that cancels the radical 3 by my x. I've got x by itself. So in your calculator, what are you typing?
31 divided by that.
Yes, 31 divided by radical 3, which is square root of 3. So 31 divide by second square root, so square root of 3. Enter. I'm getting 17.89785834. Okay, so I've solved for x. I'm going to say x equals, I'll round that up to 17.89785834. You could also put 17.89. You could do 17.8, 17.9. Lots of options. So step one was to solve for x. So we have x. Now that we've found our x value, does that tell me the length of any of my other sides? It does. It tells you EF because EF is x. So labeling your little given and find chart will really help. So I'm going to put x equals 17.90 inches. And what do I have? What do I have left to find?
Yeah.
DEF.
Would you just double your X?
Yeah,
X
just
times-
double the x times 2. So I know DF is 2 times x, and x is 17.9. So 2 times 17.9. Let's see what that gives us. I got 35.8 approximately. Now these are never going to be perfect answers because we have radicals. So I know now that DF is 35.8 inches. These were my answers. That is number 9. Do we have any questions about number 9? Or we feel good about it? Can we move to number 10, which I forgot to label with a number? I have to fix that. Okay, so we'll go ahead and scooch down to number, there's no number, but it should be number 10. I hope I didn't call the next one 10. Nope, I didn't. Okay, so there should be a 10 here. I just forgot to write it, so I apologize for that. Now we have a regular right triangle. And I don't say regular meaning all the angles and the side lengths are the same. It's just your typical right triangle. There's nothing special about it. So you have been given 2 side lengths, and using the Pythagorean theorem, I want you to solve for the missing side length of the right triangle. So we're trying to find x. So again, in case we've forgotten, the Pythagorean theorem is a squared plus b squared equals c squared. So I'm trying to solve for x. First, we need to decide what is x. Is that an A, B, or a C?
Isn't C English double?
Yes, C is my 12. Why is C my 12? Or why is
Because
12
it's
C?
the longest one.
Yes, it's the longest length. This is the hypotenuse. The hypotenuse is the one across from 90. This will always be your C. So I'll go ahead and plug in 12 for C. Now, for A and B, does it matter which one I put where? No, luckily A and B, it doesn't matter which one you put where, as long as you know that the 2 legs are A and B, not C. So I like to have my X in the front. I'm just going to call X my A. And I'll call 8 my B. So I have X squared plus 8 squared equals 12 squared. And now I have everything plugged in. So once I have it all plugged in, what will I do next? Yep, let's square our numbers. 8 squared. Well, I remember my little rhyme. 8 times 8. 8 and 8 went to the store and they bought Nintendo 64. So 8 times 8 is 64. And then what's 12 squared?
144.
144. Good. Okay, so now I have x squared plus 64 equals 144. I'm still trying to solve for x, so where do I go from here? Yes, we'll just subtract 64 from both sides. I can bring down x squared equals, let's see, 144 minus 64. Yes, that is 80. And am I done? Nope, I got one more step. Yes, this is where we square root it. Squared can be gotten rid of or canceled out by doing the square root. Those are opposites. So we square root both sides, which gets x by itself equals. And now we just need the square root of 80. And when I type that in, I am getting about 8.94427, blah, 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 blah. So I'm going to write 8.94. And my units are feet. So x equals 8.94 feet. And that is my answer for number 10. Which again, I forgot to write 10 on your quizzes or your practice finals. So if you don't see the number 10, that's why. This is number 10. All right. I'll give everybody a second to finish copying that down, and then we're moving on to Unit 3 next. Unit 3, we're looking at quadrilaterals on the next page. Okay. Am I good to flip my page? Does anyone still need to see this? Okay. Moving on to page 4. Now we're looking at quadrilaterals. We have perimeter and area, and we're also naming the quadrilaterals. So something that would be really good to note is on your final, you probably are going to have different shapes than the ones I'm giving you here. So on a sticky note, I'm going to review the different names of quadrilaterals that we might see. So we have, for example, I'll draw this shape where I have parallel sides. I have my two opposite sides are equal. So I put 1 tick mark. And then my other opposite sides are equal. So 2 tick marks. This would be a parallelogram. Now the other shape that we might see, and I'm going to give you 4 of these, is one that looks like this, where you still have the same opposite side marks. My 2 short sides are equal, my 2 long sides are equal. But I'm also given that all my angles are 90 degrees. What would this shape be? Rectangle. Good. And this all should be in your notes, but just a quick review. So we have a parallelogram, we have a rectangle, and then our two kind of special ones. Now we have one that looks a lot like a parallelogram, but all four sides are equal. So just one tick mark on every side. That's a rhombus. Good. And then last but not least, we'll have four sides that are equal, but we'll also have 90-degree angles. What would this be? A square. So these are kind of the four quadrilaterals we have focused on. These would be a great thing to keep kind of in your notes, or just to write down on your practice quiz, because your practice final. On the final exam, I'm not going to give you the same two shapes, okay? So we're trying to find perimeter and area. And we're going to remember that perimeter is just describing the distance around the outside of the shape. So that would be basically just add all the side lengths together. So I'm going to write over here, perimeter is just adding all the sides together. And area, we've got a formula. Does anybody remember the area formula for a quadrilateral? So for perimeter, we're using addition. What operation do we use when we find area? It won't be addition anymore. Yeah, it's like your length times your height. We also could say your base times your height. Both are good. Both are good. I'm going to write B times H for base times height, but you could also call it your length. Both are good. So basically, we're going to use the bottom measurement as our base or our length. And then your height, this is where we need to be careful, especially on parallelograms and rhombuses, because your height is not the same as your side length. Your height is going to be that little perpendicular line that's being drawn down the middle. So for number 11,
Your base is 55, your height is.
yes, my base is 55. My height is that 48. So we know, looking at this picture, all four sides have one tick mark. So if I wanted to, I could go ahead and label all of these sides as 55 inches. And what would I do to find my perimeter?
55 times 4.
You could do 55 times 4. There's 4 of these 55s. You could also do 55 plus 55 plus 55 plus 55. That takes a little bit longer. I'm going to take 55 times 4. And so our perimeter will be, let's see, I'm getting 220. And what would my units be? Inches. Good. Now I need to find my area. And You told me that my base is 55 and my height is 48. So let's just plug those in. 55 times 48. And when we do that, let's see what we get.
2,642.
Yes, 2,640 inches squared. Good. Different units here. Inches squared. 2,640 inches squared. And then what type of quadrilateral is this? What's the name of it? Rhombus. Good. 4 sides that are equal. Rhombus. Good. Do you have any questions about number 11? Okay, let's go ahead and look at number 12 then. I'm going to scoot that over a little. Number 12, I've got a different shape. I know all my side lengths are not equal. I like to label things before I start doing calculations. What would this top side length be?
82.
82. It's got the same number of tick marks as the other one labeled 82, so I know that. What about my smaller side?
31.5.
Good, 31.5. So I know all 4 side lengths. How could I find my perimeter?
2.
You can add all of them together. Something else I can do, as I see I've got 2 82s and 2 31.5s. I could take both of those times 2 and add them together. But if adding all 4 together is simpler to remember, you can absolutely do it that way. I'm going to do 2 times 82 plus 31.5. Let's see. 82 plus 31.5. And the answer I am getting for perimeter is 227. Let me know if you're getting the same number or something different. Good. What would I use for area? What's my base and my height here?
Base is 82.
Mhm.
Height is 31.
Good. My base is 82. This time my side length is my height because there is a 90-degree angle here. So I can take 82 times 31.5.
583.
Ooh. Yes, 2,583. And what are my units? Inches squared. Good. And it's a rectangle. Wonderful. Okay. So that was number 11 and number 12. I'll leave that up for just a minute. Go to 13 and 14. We have a couple other things we'll want to label for number 13 and 14 that'll help us out. Before I move on, does anyone need any more time to copy this down? Okay, I'm going to go ahead and scooch that out of the way. And now we'll look at 13 and 14. So for these questions, you are going to find the perimeter and area for each regular polygon. Then you're going to identify the name or the type of polygon. So another good spot to take a note is we're going to need to remember some of these regular polygon names. So these are based off of sides, how many sides. So I'm going to write over here a little list. When I have 5 sides, we'll start at 5 because I know there's not going to be a 1 side, there's not going to be a 2 side. 3 sides is a triangle. 4 sides, we already did that. So it'll either have 5 sides or more. What is a polygon with 5 sides called? Starts with a P. Pentagon. 6 sides. Hexagon. 7 sides. Heptagon. Good. 8 sides. Octagon. 9 sides. Nonagon. 10 sides. Decagon. Do we know 11 sides? This one's the hardest to remember, I feel like, because it's weird. 11agon. No, this is a hen, Hen, decagon. And we'll go all the way up to 12 sides, and we'll stop there. Anyone remember 12? Dodecagon, good. D-O, decagon. Dodecagon. So this is a great list to have because you never know how many sides I'll give you on the final, and you will need to name them. So I'll give everyone a minute to copy that down. Should be in your notes, but I know it's kind of a pain in the butt to flip through 8 weeks of notes on the day of the final.
With me, I literally only really need to write what 11 is, because
Right.
I remember 5 to 10 and 12, but 11 I could not think of.
See, and it's funny, I'm the same way. I knew all of them, but 11 I always forget. I don't know why. It just feels funny. I don't know where the hen comes from.
It should be undecagon,
Wouldn't you think?
because
Yeah, that's what in my mind I kept
undecillion
thinking.
is the number here, so it should be 11.
Makes no sense. Maybe I'll need to check my sources. Maybe it is called an undecagon in some places. That would make a lot more sense. Okay, so I'm going to stick this over to the side, and let's look at number 13. So the first thing we can do, and I would recommend this, is I would count how many sides you have because you need that number to find your perimeter and your area. So I'm going to count 1, 2, 3, 4, 5. I have 5 sides. So technically we could go ahead and name this. What type of polygon is this? Pentagon.
That one shape.
Yeah, that one shape. Okay, so we have a pentagon. We need a perimeter formula. We need an area formula. What is the perimeter formula? Does anyone remember? I had to look back at my notes just now even, so it's okay if you don't.
I know that part of it is based off of how many sides there are.
Yes.
That's about all I can think of.
So I can give you that first part. N, we're going to take N times something, N being the number of sides. Say it. Yeah, N times S, S being the side length. N times S. And S is side length.
It's just one side length.
Yeah, they just give you one side length because they're all equal, aren't they? They've all got one tick mark. And that's something that we know is a property of regular polygons. Every side length is the same. Every angle is the same. So What's N and what's S in this case?
And it's 5.
Yep. Perfect. N is 5. And S, the side length, is 28. So we're just going to do 5 times 28. And let's see what we get. I am getting 140. So my perimeter is 140. What are my units?
Inches.
Inches. 140 inches. And I'm going to highlight in another color that formula so that it'll be easy to find later. P equals N times S. Okay, and now we need area. So let's write an area formula. Area equals, and I'll just give you this one. I don't expect you to have it memorized. We're going to take the perimeter times the apothem.
believe she thinks this almost.
What'd you say?
Can't you believe that you think this low of us?
No, I don't think low of you. I just think we learned a lot in a very short amount of time. I don't expect you to retain it that well. I had to look back at my notes to remind myself too. So perimeter times apothem. What is the apothem?
It's that half manner 36.
Yeah, it's that 36 inches. It's going to be the line or the length from the center of the shape to the center of one of your sides. So we're going to use the perimeter 140 times 36, the apothem. And divide that by 2. When you get your answer, let me know. I got mine. Getting for area.
2,520 inches.
Yes, 2,520, 2520 inches squared. There we go. Okay. And that is number 13. Number 14 is the same thing, just a different number of sides. And of course, a different side length and apothem length. I'm going to move this sticky note out of the way. And we'll start the same way we did on 13. I'm going to count all my sides. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 sides. What type of polygon is that? A decagon. Okay. So that means my n, or my number of sides, is 10. What is the side length I will use? 12. So how do I find perimeter?
10 times 12.
Perfect. 10 times 12 equals 120, and it's also inches. So that's my perimeter, 120 inches.
Area
Mm-hmm.
would be 120 times 23.5.
Perfect. 120 times the apothem, which is 23.5.
2,820.
Mm-hmm.
And then divide that by 2.
divided by 2.
Yeah, 1,400.
Okay, let's see. Divided by 2. Yes, 1,410. So 1410. And our units, inches squared. Okay. 1410 inches squared. There you go. That is it for page 4. And we're almost done. We have 2 questions left on the whole final. I'll give us a second to finish up writing any of this work. And before we move forward, does anybody need more time? I don't want to have you guys sitting here just waiting on me. Are we ready for the last page? I think that's a yes. Okay, last page. Circles. We're all the way up to unit 4, the end. So we are just finding area, circumference, and we're also filling in the missing values for radius and diameter. So for number 15, well, first of all, let's write our formulas down. Area of a circle, what is the formula for that? Just took a quiz over this. Yes, pi r squared. What'd you say?
You know how many times I've slept through them?
A couple. Okay, so my area is pi times the radius squared. What's my circumference? There's 2 options. Pi times the diameter. Or, I guess you could also do the 2 pi r. Both work, both work. Now, if you forget these formulas, I do have a little poster over on that wall by the door that has all the formulas. So if you forget, just look over there on the wall. So now that we have the formulas, let's look at 15. I'm given a measurement of 45 inches. Is this a radius or a diameter? It's a diameter. It goes all the way across the circle and it looks like a capital D. So 45 inches is my diameter. So how do I use that to find the radius?
Divided by 2.
Just divide it by 2. So the radius is going to be 45 divided by 2. And I'm getting 22.5 inches. So we'll put that in for radius, 22.5 inches. Now that I have radius, we can find area and circumference. So what would I type in to find area?
Pi,
Mm-hmm.
22.5 squared.
Yes, pi, 22.5 squared. And remember your pi button. If you forgot, you can access that by hitting the second button, the blue button, and then that up arrow right under clear. There's a little pi symbol above it. Up arrow. And now you have pi. Second up arrow. Then 22.5 squared. Oops, I don't mean to do that. I'm getting 1,590.43. Okay, good. We're getting the same thing. Okay, so area is 1,590.43. What are my units?
Inches squared.
Inches squared. Is that exact or approximate?
Approximately.
Approximate. We need the tilde. technically, we really could have put the tilde on a lot of our previous answers, but we didn't really introduce it until the circle unit. So as long as you just have it on these, that's okay. What would our circumference be? What can I use to find circumference?
Pi times 45.
Yes, pi times 45, the diameter. And I'll type that in. I'm getting 141.37. Good. 141.37 units. What are my units? Inches. Put a tilde up. Hey,
It's really raining outside.
I know, it's been raining like crazy.
Yeah.
It's storming.
According to the weather, pretty much every day this week, that's a
Really?
single day, it's gonna be raining.
Man,
Makes it real fun for me.
I bet. Walking in the rain is not fun.
Actually, this time you brought paper, plastic bags to.
Yeah.
To put over my shoes.
Hey, it
That
works.
helps.
It probably will. Probably will. I've had to do it before. Okay, last one, number 16. I have another circle and I'm given a measure of 21 inches. Is this a radius or a diameter? It's a radius. 21 inches. So what's my diameter? 42 inches. You just take the radius times 2. So diameter equals 21 times 2, which is 42. 42 inches. Okay, so now we can find area and circumference. Same thing. Area is pi times the radius squared. Am I using 21 or 42? 21. We're going to have some pretty similar numbers. I didn't realize how similar those were. Okay, so second pi 21 squared. I get 1385.44. Inches squared with a tilde. And for circumference, I'll take pi times what? The diameter, 42. So, second pi 42. And I get 131.9, I'll round up to 5. 131.95. Units, inches, and it's approximate. Okay, that's your final. It's just 16 questions. I just wanted to touch from everything we've learned this term. This is it. You guys are about to be completely done with geometry. Pretty crazy. So all that's left is the bonus question, which is completely optional. You do not have to do it, but I'll run through it with you just to give you an example. Let's see here. So for your optional bonus, we are finding the area and the perimeter of a combined shape. Meaning, yes, there are lines here between these semicircles or these half circles and this rectangle, but the whole shape is this. This is the shape. So we're going to think about that when we find perimeter. So the shape is composed of a rectangle and two congruent or equal halves of a circle. So we're going to need to find the area of the rectangle. We're going to need to find the area of the two halves of the circle. And then we're going to want to find the perimeter of the whole shape. So
Here's the part where you cut.
it's a bonus. Come on. It's all right. So let's find the area of the rectangle. How could I do that? What is the formula for finding rectangle area?
Based on site.
Base times height. Area is base times height. What is my base in this scenario? 50. What's my height? 45.6. Okay, and then we'll have the area of our rectangle here. So 50 times 45.6. And I'm getting 2280 or 2,280 inches square. So I have half of my problem for area done. I know the area of the rectangle part is 2280 inches squared. So I've gotten this part of the area, but I also need to find the area of these two halves of a circle. Now, it's not as difficult as you might think, because if I know that these are halves of a circle, when I put them together, it's just a circle. It's a whole circle. So I just need the area formula for a circle. But how am I going to know the radius of this circle? Because I need that for area, don't I? Area is pi r squared. Why don't I pull these two halves out and draw my circle? And I see that right here, this half of the circle does have a measurement labeled.
Oh, I get it now.
Ah, you get it now. What is my measurement here?
Maybe 45.6.
Yeah, it's 45.6. Is this a, what is this?
That'd be a diameter.
A diameter. So what's my radius?
Radius would be 22.8.
Yes. You're just going to divide that by 2. 45.6 divided by 2 is 22.8. So I can find the area now fairly easily. The area of my circle is pi times radius squared. So pi times 22.8 squared. I am getting approximately 1633.13 approximately.
So it just add two areas together.
Yes, you just add the two areas together. So it would be a good idea to keep track of the areas you've already found. I found my rectangle and I just found my circle, 1633.13 inches squared. And the whole shape is just the rectangle plus the circle. So the area, because we just add them together, 2280 plus 1633.13. And let's see what I get. I just added them manually. I got 3913.13. Does that look right? Okay, good. Okay, so my area is done.
So like with the perimeter, what you do the perimeter of the square and then perimeter of the circle with this the diameter. Then
You're very, very, very close. We want to find the perimeter of the whole shape. So we really want to think about what is on the outside of the shape. Would I include this length in my perimeter? Is this on the outside? It is of the square, but we're going to pull this out and remember the whole shape is this. We have a length here that I know. I have a length here that I know. Like over here, this was labeled as 50. And then these had the same number of tick marks. So what would this side length be? 50 also. And then I need to know the circumference of my circle will give me perimeter, won't it? This is the outside of the shape. What this 45.6 does is it just acts as a height. Because the perimeter is just the outside of the shape. We're not going to use any of the inside measurements. So, what will I do to find the perimeter of the whole shape? What's something I could find first? Go ahead, sorry. Yeah, let's find the circumference first because the circumference gives me the length around the circle and that will at least give me this part. And then I just need the other two sides that are on the outside. So let's find circumference, which is pi times diameter. And I know my diameter. Pi times 45.6. And I got 143.2 round up to 26. Okay, so I know the circle part, but what else do I need to get the whole perimeter? Have this part done.
The other two side lengths of the.
Yeah, I just need the other 50 side length and the other 50 side length. We're just looking at the outside of the shape. We got circumference, that knocks out the two circle halves. And then the only thing left is the 50 and the 50. So you're just going to add that to your circumference. Plus 50 plus 50. And I got 243.26. And that's your whole perimeter. You ready? Okay, does anybody have any final questions about anything we just went over? It's
For the finals, are we allowed to use like notes or anything?
Yes, yes, your final is just like a quiz. If you are ready to take your final today, or if you want to at least get started on it, I do have it ready and you're welcome to do that. Yes.
I'm ready to take it.
All right. Okay, well, I'm going to go ahead and end this recording and get it uploading. And if you want to take the final now, bring me your practice final. I'll make sure it's filled out. I'll check it off. And then you may begin. That's it, guys.